So for our day 2, we're going to talk about a couple more ways of describing these polynomial functions. So one way is with an even or odd function. An even function is symmetric over the y-axis. So that means one like this would be even. You can fold it in half. Or maybe you see one like something like that. What this means is f of negative x is the same as f of x. So if you have an x value here, it's the exact same height as that negative x. Odd function is symmetric about the origin. I like to think about this as you can rotate it 180. And it's the exact same. And this means f of negative x is the same as the opposite of y value. So indicate whether these are even or odd. So we can test out this property. If it's even, f of x cubed equals that same. Well, we know a negative cubed, the negative comes out in front. So it's not even. And if it's odd, f of negative x equals the opposite of the entire function. Well, negative 5x cubed, that would come out in front. So this would be odd. Well, what about this next one? Even. So let's check that. And if it's an even power, I usually check the even first. So 5 times negative x to the 4th plus 2 times negative x squared minus 6. Does that just equal 5x to the 4th plus 2x squared minus x? Well, we know an even power, if the exponent of a number is even, then that number is just going to be even. So this is 5x to the 4th plus 2x squared minus 6. So yes, this is even. So what about this last one? Does 4x cubed plus x equal the same if we put in the negative x? Well, that's not true, because those negatives would stay, so it's not even. So let's check odd. Does 4 times negative x cubed plus negative x, does that just equal the opposite of the entire function? Well, let's see, negative 4x cubed minus x, if we distribute that, negative 4x cubed minus x. So yes, it does. So this is odd. So let's take a look at the last thing for this section is polynomial inequalities. So just a reminder, when we write f of x, we're referring to the y value on the graph. So if we're saying when f of x, when y is greater than 0, we're saying where is it above the x-axis? And when we're saying when it's less than 0, we're saying when is it below the x-axis? So if we take a look at this function, first question is when does it equal 0? Here, here, and here. So at x equals negative 3, x equals negative 1, and x equals 3. Where is it f of x greater than 0? Well, it's greater than 0 between negative 3 and negative 1, and in between 3 and infinity. And you'll notice I use brackets because it just wants it greater. Where is it less than or equal to 0? So where is it underneath? Well, right here, and it's less than or equal to 0. So negative infinity to negative 3, and I'm going to put a bracket. And then again, it is from negative 1 to negative 3. Now, how do we do this, though, if we don't have the graph? So the first thing is we set it equal to 0 and we make a sign chart, and we test values to see if they are positive or negative. And then we interpret our sign chart. So you want to make sure you write it in interval notation and think about that inequality sign. So for example, this one, well, it's set equal to 0. Okay, so let's see. Where are our zeros at? So 3, negative 1, and negative 4. So I'm going to make a sign chart with negative 4, negative 1, and 3. And now I'm going to test a value. So for example, I'm going to see, when do I put in -5? -5 minus 3, -5 plus 1, -5 plus 4. Is that greater than 0? So this is -8 times -4 times 1. Is that greater than 0? Well, that's 32 is greater than 0. So this turns out to be, whoops, positive. Did I do that right? -5 minus 3 is -8. -5 plus 1 is -4. -5, oh, this is -1, so that's -32. My bad there. So if that's -32, this area right here is negative. So what's a number in between here? Could be -3. So let's test that one. -3 minus 3, -3 plus 1, -3 plus 4. Is that greater than 0? Well, this is -6, -2 and 1. Well, that's 12 is greater than 0, so this is positive. Well, what's a really easy number in here is 0. So if I did 0, 0 minus 3, 0 plus 1, 0 plus 4, is that greater than 0? So -3 times 1 times 4. Well, I know that's going to be negative. And then let's see, let's try 5. All right, so 5 minus 3, 5 plus 1, 5 plus 4 is greater than 0. So 2 times 6 times 20. Well, I know that's going to be greater than 0. So that's also positive. So again, our answer, we want to know when it is greater than 0. So that's here and here. So the answer to this problem, we could say from -4 to -1, and then again from 3 to infinity, and that would be our answer. So let's try this next one. Well, if I solve it, it's just -2 and 5, so that's nice. So what points could we test? Let's try -3. -3 plus 2 squared, -3 minus 5. Is that less than or equal to 0? Well, -3 plus 2 is -1 squared is 1 times -8. Well, that's negative. Again, I always like to test 0. 0 plus 2 squared, 0 minus 5. Is that less than or equal to 0? So that's 4 times -5. Well, that's negative. And then one bigger. So let's try 6. 6 plus 2 squared, 6 minus 5. Is that less than or equal to 0? So 8 squared times 1. No, because this is positive. So I guess I apologize. We really don't need these less than zeros. We're just trying to find out if it's negative or positive. My bad, you guys. I don't know why I was putting those in there. So we want to know when it is less than 0. Well, that is right here. So then our interval would be from -infinity. And you see how it's equal to? So 5 with a bracket.